We all have muscle, whether we're bodybuilders or couch potatoes. But we all have muscle. Skeletal muscle is one of the 3 types of muscle in the muscular system, and one of its main functions is movement for the body. But how does movement occur? With contractions. The process of contractions digs into the sliding filament theory. The sliding filament theory begins deep into the muscle with the myofibrils, which contain small sections called sarcomere, in which thin and thick filaments are located, as well as the Z-line and the M-line. The thin filaments found in every sarcomere is called actin. Actin has tropomyosin ribboning around it and troponin, small receptors, connected to it to help it function properly. The thick filaments are called myosin. At the end of this protein are myosin heads, which work with the actin in the sliding filament theory. The Z-line is located on the sides of the sarcomere, and its duty is to separate one sarcomere from another. The M-line is a line in the center of the sarcomere, in which the actin, when contracted, can go to but cannot pass. The phosphate molecule is located at the end of every myosin head, and alongside it is an ADP molecule. When the brain triggers the muscle to contract, the sarcoplasmic reticulum releases calcium. The calcium comes down to the actin and binds to the receptor troponin. This changes the shape of the actin, creating binding sites for the myosin heads to connect to. The phosphate molecule is then released from the myosin head, which allows the myosin head to ratchet onto the binding site that the calcium and the actin together have created. Next, the ADP molecules are released, causing the myosin heads to pull the actin proteins towards the M-line in the middle of the sarcomere. ATP molecules then come in, replacing the phosphate and ADP molecules at the end of myosin heads. They are then released, causing the myosin heads to unratchet from the binding sites on the actin. This allows the myosin heads to reposition itself for the further process. And then the ADP and phosphate molecules come in and replace the ATP, and the whole process starts again. This process continues until the actin proteins reach the M-line in the middle of the sarcomere. At this point, the muscle is contracted as much as possible, and that sarcomere goes back into its relaxation phase. The same process happens, but instead of the Z-lines in the actin moving towards the M-line, it moves back out into its original position. And this is the sliding filament theory.